In this video, we are going to see the algorithms for query processing. So basic algorithm for query processing. In the query processing, we have select operation, project operation, join operation, and set operators, and also so many operators are available in the relational model. So in this slide, in this video, we are going to see the algorithm for select operation, join operation, project operation, and set operations. So here some examples are given. The first one is retrieving the employee details using the primary key column SSN. And second one is retrieving the department values using the primary key column department number, but other than equal operator, that is a greater than 5 is given here. Okay, and third one is retrieving the employee details using the foreign key column. Okay, foreign key attribute department number equal to 5. So what are the various methods, algorithms are available for this type of operations? Okay, so see that here all the operations are contained the simple conditions, only one single conditions. So here so many methods are there. So the first one is okay, and the values are retrieved using the entire file without any index structure, means that is called as file scan. So directly the database file will be accessed and condition will be checked, and the what are the rows are satisfy this particular condition, that will be retrieved from the database file itself. That is called as the file scan. Okay, and the same thing, the records will be retrieved using the any index structure. Okay, access path programs, means that is called as index scan. So without index file scan, if you are using any index, if any index concepts are used in the algorithm, means that is called as index scan here. Okay, so the first one is linear search. That is the brute force algorithm. So this is the basic search, not using any alga index structures. Okay, so each and every record will be compared with the given input value, and satisfy means that particular rows will be retrieved. For example, sigma SN equal to some value of employees given. No, so the employee table will be taken. In the employee table, so many attributes are there. The primary key attribute is the SSN. Okay, so that value given input is compared with the employee relations SSN attributes, each and every value. If matching, that particular row will be retrieved. That is a concept of linear search. So yeah, from the data file, every record will be retrieved, and that particular record have this given input value under the SSN or not, it will check. If satisfied, that particular row, particular tuple will be coming in the result. That is the linear search. Okay, and second one is binary search. So in the binary search, based on the key attribute. Okay, so the key attribute based on the key attribute, the records, everything will be arranged in the ascending order or descending order. Okay, then the binary search, suppose the second one, D number greater than 5 is given. So greater than 5 means so one particular part of the file only contain the particular values greater than 5, or the above 5, what are the rows are there, that value we need for that. So in this binary search method will be used. So based on the primary key column, that particular data file will be arranged in the ascending order, and then the middle value. Okay, so in the department number, under the department number, middle value, based on the middle value, the data file will be converted into the two part. Okay, so less than that middle value one part, above is the another value. So now the condition D number greater than 5 is given. No, that 5 is coming under which part? Based on that, that particular part will be taken, and the particular rows will be retrieved. That is a binary search. Okay, so in the operation one, sigma SSN, based on the SSN, the employee table will be arranged in the ascending order. So based on the middle value, first part and second part, which part contain these values. Okay, so these values compare with the middle value, and less than means first part will be taken for the comparison purpose, and given input is above the middle value means second part of the employee file will be taken for the comparison purpose. Okay, so the number of comparison will be reduced using the binary search method here. And third one is using a primary index. So primary index, the index created using the primary key value. So in the primary index concept, first data file will be everything put into the data block. Okay, each and every block contains the fixed number of records, and the data file will be arranged in the order based on key column. Okay, and each and every block first record will be stored as a key in the index. So your input values compare with the index value, index key value. So based on that particular data block will be accessed, and particular record will be retrieved from that particular data block only. Okay, so here also the number of comparisons will be reduced here. Okay, and second third is third method. First one is primary index, and second one is hash key, using hash key. Okay, so the hash technique will be used here, and so based on the hash technique, hash key. Okay, based on the hash key, that particular row, the conditions given no in the select, so that particular condition will be uh, which bucket contain that particular record, that will be identified using that hash key. Okay, so the records, everything will be put into the buckets using the hash function, and that hash key will be used to retrieve the particular record. Okay, that is using hash key. And next is using a primary index to retrieve multiple records. So your condition in the select operation, the condition contains any other than equal operator. Okay, so greater than or less than or not equal to means we will get multiple records. Okay, so that time this algorithm will be used to retrieve the multiple records. So using primary index to retrieve the multiple records. Okay, so in the example, second operation, d number greater than 5 is given. So the first the record, everything will be data file, everything arranged in the order based on the primary key. Okay, so now here example department number greater than 5 is given. So once the greater than 5, that is the compare with the 1 is less than 5, and 2 like that up to 5, the 5 is not greater than 5, that is equal to 5 only. So once it's reached the 6, there is no comparison. After that, what are the records are there, that everything will be retrieved, because the data file is arranged in the order based on the primary key. Okay, so the primary index once reach this condition d number greater than 5, immediately the remaining everything will be retrieved, and that will be added to the output that will be shown to you. Okay, so this is the and department of less than 5 means preceding records, everything will be like retrieved using that. So and up to that is the simple conditions. Only one condition is available means we will use a linear search method or binary search method, and hash key method and primary index method, and multiple record means the same primary index will be used. Okay, now complex selection. Complex selection means a single query contains more than one condition, that everything will be connected with the AND operator. AND operator here. Here one example is given. Three conditions are given: d number equal to 5 and salary greater than 30,000 and 6 equal to f of the employee, and one more also given. Both are contain more than one condition in the select operator. So this everything coming under the complex selection here. Okay, so for that, the first algorithm is conjunctive selection using an individual index. So the individual index means you see that in the d number equal to 5, salary 6 equal to 5, f is there, no? So this everything will be taken as a individual condition that contains coming under the simple selection condition. So in the simple selection conditions, we discussed no linear search, binary search, primary index, hash key, and retrieve multiple records. So any one method will be applied for d number equal to 5 and separately, and salary greater than 30,000 separately, and 6 equal to f separately. So then finally everything will be combined using the AND operator. Okay, simple condition and the conjunctive select and the access for one of the methods here. Okay, and whether each retrieved records are satisfy the remaining simple condition in the conjunctive selection condition or not, it will check. So first, t number equal to 5, it will be retrieved using any one of the linear search or binary search or primary index. Then that output compare with the salary greater than 30,000, then 6 equal to f. Okay, so that is the conjunctive selection using an individual index. Okay, and conjunctive selection using a composite index. So how many conditions are there? That number of key values will be present in the index. Okay, so the composite index will be created. Composite index means more than one key value will be there in the index along with the pointer. So more than one key value based on the number of attributes mentioned in the selection condition. Otherwise, the as structure will be used. So in the example, employee number and P number in the works on table, one operation is given using the employee number and P number values. So the one index, complex index will be created with the both attributes, employee number, P number, key values. So based on that, values, everything will be retrieved. Okay, and next one is selection by the intersection of record pointer for the complex selection. Okay, so the secondary index concept will be used. So secondary index means uh, we have the multiple records. Okay, with the same value, multiple records are available means the record pointers will be identified. Okay, so now the example. Okay, so in the example, you see the D number equal to 5. So D number equal to 5 related record pointers will be identified. Okay, so what are the data files pointed by the record pointer that will be identified, and salary greater than 30,000 that will be identified. Record pointers will be identified. Then 6 equal to F record pointers will be identified. Okay, so one particular row contains all these three values: department number equal to 5, salary greater than 30,000, and 6 equal to F. No, so that corresponding records pointer will be available in all three sets. Okay, first set contain the record points of department number equal to 5. Second set contain the record pointer of salary greater than 30,000, and third set contain the record points of 6 equal to F. So one particular tuple have these three value means that particular tuples record pointer will be available in all three sets. So the intersection will be applied among the all three sets of record pointers, and what are the record points are common that will be identified based on that record pointer. That corresponding tuple will be identified. So that particular tuple have this all three values. Suppose three conditions are there. Suppose four condition means four record pointers available in all four sets. Okay, same record pointer. That particular will have the four values. Okay, so that is the concept of the conjunctive selection by intersection of the record pointers. Okay, so these three methods are used for the complex structure. Okay, so first one is conjunctive selection using an individual index. Okay, and the second one is conjunctive selection using the composite index, and the third one is conjunctive selection by the intersection of record pointers. So this everything implemented using the index concept only. Okay, index concept. These are the various operations algorithms for the select operation. Okay, so simple means very basic algorithms are used, and complex selection operation means the basic algorithms along with some more concepts, that is the index, hash index, or any index methods will be used here. Okay, so these are the various methods for the select operation. And